When we talk about safety out here, we're really talking about having the right attitude about your work to keep everyone safe. Most of the time, we're working on things that could present a hazard and result in injury, making life pretty miserable for you and everybody around you. So it makes good sense to work safely. For example, it's important to isolate equipment you're working on to prevent unexpected startup. Like most of our safety procedures, energy isolation involves common sense. We have specific rules and procedures that are to be followed in specific situations, and those rules are there because they work. Please follow them. There are potential sources of energy and hazardous material on nearly every site. Some of those potential hazards include electrical. Contact with energized circuits, unexpected energizing of the circuit, or unexpected startup of the equipment can all cause serious injury. Mechanical. The danger here involves exposure to moving machinery or equipment components like gears, levers, fan blades, pump shafts, and couplings. Be sure to identify power sources for equipment like electric motors, engines, and turbines. Pressure. It's important to evaluate pressurized systems such as pneumatic, hydraulic, and steam. Such systems may release gases or liquids from tanks, pipes, or valves. The accidental release of those gases or liquids can cause serious injury. Thermal. You can be severely burned by accidental contact with steam systems, open flames, LPG gas, burners, heaters, and so on. Stored energy. Chemical batteries, electrical capacitors, mechanical springs, gravity systems, heat storage devices, and so on all contain stored or potential energy. If that energy is released unexpectedly, workers could be injured or damage to equipment could result. Hazardous materials. The accidental release of hazardous materials can cause exposure to toxic, flammable, or oxygen-deficient atmospheres. To work on equipment safely, it's important that the equipment first be isolated from potential energy sources. Now, this prevents any action that could result in exposure to hazardous materials, equipment starting, or that would allow liquids, gases, or electrical energy to flow to the equipment. The preferred methods we use to isolate energy are lockout tagout, which is used to isolate electrical energy, mechanical energy, and liquids or gases. Blinding, which is used to isolate liquids and gases, heat, pressure, and hazardous materials. If blinding is not possible, alternative methods like disconnection, double block and bleed, or single block can be used. We'll talk about these things in more detail later. There are 3 times when you must isolate all potential energy sources. Before work is done on any equipment, whenever equipment is not safe to be in operation, when equipment is to be taken out of service for any length of time. Remember, when you're working on equipment out here, there are many sources of energy that can cause serious problems. If you recognize and isolate those energy sources from the work, you keep the job safe. When you work on a piece of equipment, you often use knowledge about different types of energy isolation. You may have to stop pumps, de-energize electrical motors, and block liquids and gases to make a repair. While we'll look at these isolation issues separately, remember they're all parts of meeting the whole safety challenge. First, let's look at isolating equipment from electrical energy, mechanical energy, and fluids. The procedure for this type of energy isolation is lockout tagout. Lockout tagout is used frequently when servicing equipment. So it's important to know the procedure and follow it exactly. On an annual basis, all workers should perform lockout tagout procedures in front of a supervisor. In the U.S., a written evaluation of lockout tagout procedures is an OSHA requirement, but it's a good practice to keep current with procedures everywhere. Turning off a local switch does not de-energize a piece of equipment. Only part of the energizing circuit is broken. An override, a faulty switch, or someone turning on another switch could start the equipment. To properly de-energize a piece of equipment, you have to disconnect the power supply, properly fill out a tag, and lock out the equipment. Then you must clear the area and try to start the equipment. Just locking out a piece of machinery doesn't necessarily mean you're ready to start work. If there's mechanical energy that can be released, it must be physically restrained with blocks, chains, or other approved methods. Do not just use brakes if they're available, and all springs either have to be restrained properly or released completely. Equipment must also be isolated from all liquids and gases. This can be done by chaining and locking valves or by removing valve handles. Let's see what it takes to properly lock out and tag a piece of electrically powered equipment. First, let's start with the supplies you'll need. Every location should have an adequate number of locks, multi-lockout devices, and tags. Each lock should be individually keyed so that no one but the person doing the work can unlock it. At some locations, locks may be color-coded to easily identify the specific department or craft involved in the work. Multi-lockout devices are used when people from more than one department or craft are going to work on the locked-out equipment. Each person should apply his or her own lock and tag to the multi-lockout device. A group's work leader may place one lock on the lockout for that group if all workers initial the tag. Tags identify the equipment that has been locked out and why it has been locked out. Tags are standardized with the warning, "Danger, do not operate." Tags may look slightly different for different companies, but they're all there for the same reason, to provide an easily understood warning. You should check with your supervisor for the exact type of tag to use at your location. Tags must be secured with strong wire greater than 50-pound test string or other acceptable means such as plastic tie wraps. They should be strong enough to withstand environmental conditions. In harsh environments, tags should be plastic coated or otherwise able to withstand the environment. Tags have to be completely filled out with a permanent marker before you attach them to locks or equipment. They must have the name of the employee doing the work, the equipment name and identification, adequate description of the work being done, and the date and time the tag is being attached. Tags are also used to mark equipment out of service that cannot be locked out. Tags are not substitutes for locks. They can only be used without locks when other types of isolation have been used. In cases like these, qualified personnel can remove fuses, open a breaker, or block a control switch. When a tag is not easily visible, you can use flagging material to show its location. Check your company's safety manual for specifics on colors. Remember, never use a flag without a tag. Now let's take a look at a typical isolation example like a pump. Here are the correct steps for isolating energy and fluids in this situation. First, review the written procedures. These written procedures should tell you what work clearances and permits are needed for the job. Next, the operator and all personnel involved in the job should do an initial evaluation. This helps identify all the potentially hazardous energy sources for isolation. Then go ahead and get the necessary clearances and permits before proceeding. When you've got all the clearances and permit work in order, and the initial evaluation is complete, it's time to let everyone involved know that you're going to turn off the power. A sudden loss of power that no one expects could upset processes, damage equipment, or worst of all, cause personal injury. So be sure to tell everyone that needs to be told. After you've completed these steps, the operator can shut down the equipment by turning off the power at the local on-off switch. If the circuit breaker for the equipment is located elsewhere, be sure to tag the local on-off switch. When you operate a disconnect switch or breaker, stand to the side of the switch and turn your face away before throwing the switch. This will help protect you if there's an unexpected arcing or flash when the switch is thrown. Power distribution switchgear that is 4160 volts or greater should be operated only by electricians during routine operations and maintenance. Never disconnect the power of equipment that's under load. Shut down the equipment first at the local on-off switch, then disconnect the power supply. The equipment can now be locked out and tagged. The best procedure is to do it this way. Lock. The unit or facility operator should apply the first lock. Then each involved department should attach its lock in a predetermined order. The operator should ensure that all energy isolation devices are recorded on the energy isolation list. Remember, the lock is for your protection, and keeping the key helps guarantee your safety. Each employee should return the key to the master lockbox. Tag. If you put a lock on a piece of equipment, you must tag it. Complete all the information on the tag before you attach it. The unit or facility operator should be the first to tag. Then everyone else involved in the lockout should tag his or her lock. Clear. You must always try to operate the equipment before you start work on it. But before you do that, clear all people and tools out of the work area. Try. This is the fourth step in the lockout tagout procedure. After you've done the other steps, try to start the equipment with a local on-off switch. This is a vital step because it verifies that you've de-energized the correct circuit and no overrides exist. After trying the local on-off switch, be sure to leave it in the off position. If you try and the equipment starts, contact an electrician. Remember these four important steps: lock, tag, clear, try, always in that order. If you follow those steps, everyone will feel confident that work can be done safely. Locks and tags must remain in place until work is complete and equipment is ready to be placed back in service. Lock, tag, clear, and try are the key steps for electrical isolation. But let's say you were going to change the mechanical seal on this pump. After completing electrical isolation, you would continue isolating the pump by closing, chaining, and locking first the suction, then the discharge valve. Then open the bleeder valve to relieve pressure. Now tag all three valves. Only after completing all these procedures are you ready to replace the mechanical seal safely. There are times when an entire crew or work group is involved in servicing or maintaining equipment. In this case, the group's supervisor or leader has the primary responsibility for ensuring that energy sources are isolated before work begins. But each worker must either initial the original tag or apply a tag when beginning work on the isolated equipment. The operations first-line supervisor determines when the special situation energy isolation procedure will be used. In this case, the unit operator will be the sole person to install or oversee all non-electrical isolation devices. Any electrical devices that are isolated must be locked out by all groups involved. The unit operator logs all energy isolation devices used on an energy isolation list. Designated employees from each craft must review the energy isolation list with the operator and log the names of all personnel under their responsibility on the group employee verification record before work begins. The designated employee must sign in and sign out all personnel on his list at the beginning and end of each shift or until the job is complete. At a shift change, responsibility and documentation are handed off to authorized people on the next shift. Once work is complete and the equipment is ready to be put in service, each employee should remove his or her own lock and tag. The operator is always the last person to remove a lock and tag, and the operator should also remove the multi-lockout device. All the used tags should be destroyed unless they are the reusable type, which can be cleaned with a solvent. Locks and tags should be removed only by the person who applied them. If that's not possible, or in an emergency, and only after assuming full and complete responsibility, the supervisor may remove them with a bolt cutter or other metal cutting device. Then the supervisor must tell the employee that this action took place and why. Locks and tags should be removed only by the person who applied them. If that's not possible, or in an emergency and only after assuming full and complete responsibility, the OEM or designated person may take the key from the lockbox and unlock the lock. Then the OEM must tell the employee that this action took place and why. Locks and tags should be removed only by the person who applied them. If that's not possible, or in an emergency and only after assuming full and complete responsibility, the supervisor may remove them with a bolt cutter or other metal cutting device. Then the supervisor must tell the employee that this action took place and why. Before putting equipment back in service, inspect the equipment and the area to be sure there's no incomplete work and that there are no people, tools, or other obstructions in the way. Now reverse any isolation procedures you followed other than electrical lockout tagout. In our pump example, you would close the bleed valve, unlock and open the discharge valve, then unlock and open the suction valve. When you're ready to start the equipment, be sure to stand to the side of any breaker or disconnect switch and turn your face away before you close the switch. Then you can start the equipment using the local on-off switch and set any levels that require adjustment. Your job is now completed safely. The lockout tagout procedure is for everyone's protection. If you follow these steps exactly, you're helping create a safe work environment for you and your fellow workers. Lock, tag, clear, and try are 4 words that can prevent injuries. Many of the liquids and gases on the job are toxic and under enough pressure to cause serious injury. Lockout tagout procedures are good for isolating electrical and mechanical energy and can also be used to isolate fluids, for example by closing, chaining, and locking valves. At the beginning of this module, we mentioned that we can isolate fluids in various ways: blinding, disconnection, double block and bleed, and in very rare cases, single block. Blinding is always the preferred method of fluid isolation, and we will now discuss it in more detail. Blinding stops flow through a line completely by placing a properly rated blind in the line. Most blinds fit between flanges in the line. Blinds known as blind flanges are used to cap the ends of open lines. Blinds prevent the flow and release of materials into the work area and ensure that the blinded equipment will stay isolated from potential hazards. Some of the more common situations that require blinding are confined space entry, welding, commissioning or starting up new equipment, maintenance, repairs, and extended equipment shutdown. Let's take a look at some of these situations. For vessel and confined space entry, there are both government and company standards, and they require blinding at the closest, safest practical point to the space being entered. All lines and fittings that open into the space or vessel must be blinded. This protects you from any unexpected release of materials into the work area. When you blind for welding or burning, you isolate lines and vessels the same way, always at the closest, safest practical point to the welding site. Startup, maintenance, and repair of equipment frequently call for blinding. Blinding isolates other areas from pressure testing and the purging or flushing of lines. To protect people and equipment, be sure to blind open piping when extended shutdown of equipment is necessary. When blinding, locate the best spot to place a blind. You should also find an alternate location that will work as well. The best location to use is one that has the safest, easiest access, so you won't have to use ladders or scaffolding. Second is closest to the isolated equipment, because that avoids long lines of piping that have to be purged of gas or liquid. And third, the location that gives you the ability to bleed trapped pressure before the blind is removed. When you get ready to blind a line, it's always important to know the type of flange used at the blind location. There are 3 types of flanges in common use. Flat-faced flanges have flat mating surfaces and need blinds and gaskets that are flat and smooth. Raised-faced flanges have gasket mating surfaces that rise above the surrounding flange surface. Ring-type joint flanges have matching grooves in their mating surfaces. A matching metal ring installed in the grooves provides a seal when the flange is tightened. There's not always dependable information about the flange type on the flange itself. If piping and instrumentation diagrams, or P&IDs, are available, it's vital in planning to check the P&IDs for flange information. All flanges have pressure ratings, and the ANSI or API ratings should be stamped on the flange. ANSI stands for American National Standards Institute, and API stands for American Petroleum Institute. If you can't read the rating, contact your facility engineering group or operator. The pressure rating is critically important in choosing the right blind for the job. There are three types of blinds in common use: the slip blind, the spectacle blind, and the blind flange. They come in different sizes and ratings. The slip blind is a solid circular metal plate with a T-handle. Slip blinds are inserted between flanges to prevent flow in either direction. The T-handle must extend above the outside surface of the flange by 2 inches. The spectacle blind is a combination blind and spacer made from the same piece of material. It looks like a pair of glasses with one open lens and one solid lens. The spectacle blind is used where blinds are turned frequently. The spectacle blind is a part of the equipment, maintaining proper spacing when not being used as a blind. Using a spectacle blind means that a properly rated and typed blind is available at all times. When the open end shows, the line is blinded, and when the solid end shows, the line is open. A blind flange is a pipe fitting used to cap the flanged end of a pipe or valve. Normally, a blind flange does not have a handle, and it's the only blind that has holes in it for bolting to the flange. All other blinds must fit inside the bolt pattern of the flange. A blind should always have one of these characteristics: a T-handle, an open lens, or it caps the end. Remember, if you don't see one of these, do not assume a line is blinded. There are other inline devices like spacers that can be mistaken for blinds, and if you're not careful, could cause serious trouble. In addition to different types and sizes for different flanges, blinds also come with various pressure ratings. As we showed you earlier, all flanges have pressure ratings. When using a blind between flanges, the blind must have the same or higher ANSI or API pressure rating as the flange, or sufficient rating to withstand the expected maximum operational pressure. If you have any question about the pressure rating of a flange, use a higher rated blind. When planning work, you should always have the right number, type, and size blinds for the job. Sometimes, though, you may make a blind in the field, but it's not a recommended procedure. Sizes, thicknesses, and pressure ratings of materials for blinds must be checked by referring to engineering or to published specifications before you fabricate a blind. Blinds that you make in the field should have a T-handle that sticks out 2 inches beyond the flange, with a hole drilled for attaching a tag. You should also stamp the blind with its pressure rating. Some blinds are made from materials that aren't normally available at work sites, so be sure to obtain those blinds only from an approved source before you begin work. Blinds for ring-type joint flanges should always be obtained through an approved manufacturer who designs blinds specifically for the flanges you're blinding. Never try to make an RTJ blind yourself or try to use one that has not been manufactured to proper specifications. In addition to flanges and blinds, there's a third important component used in blinding: gaskets. Gaskets are an important part of good blinding procedure because they complete sealing of the flange. Selecting the right gasket is as important as selecting the right blind. Always use a new gasket when blinding. Never try to recycle a gasket or an RTJ ring. A new gasket is cheap insurance against flange leaks, which can be both dangerous and costly. The gasket or ring you choose should be the right size, type, and rated pressure for the flange, and be the right material for the temperature or substance in the line. The size and pressure rating are stamped on the package or the gasket. If you have any doubts about a new gasket, if it's crimped, cut, gouged, or doesn't fit smoothly on the flange, throw it away and get a new one. Remember, you could be betting your life on the quality of the blinding job, so take the time to do it right. Now let's go over the procedures for installing and removing blinds, including developing and using a complete blind list, site preparation requirements, installation procedures, tagging requirements, and blind removal procedures. Developing an energy isolation or blind list during the planning phase will help you obtain the right blinds for the flanges involved. Each blind list entry should include the blind number, a description of the blind location including line number if applicable, the date of the installation or removal, and the name of the person installing or removing the blind. The list should also contain the blind size and pressure rating. During the planning stage, you may need to process permits. You'll want to refer to the safety manual to see what permits apply to your specific situation. During the planning stage, you may need to process permits. The Safety Handbook contains a tabular Guide to Standards and Permits that shows permits required for tasks. Once you've got the proper paperwork done, it's time to do site preparation. Site prep involves making sure you've got the right tools, blinds, gaskets, and any required safety equipment. Some important tools that might be necessary are scaffolds, spreaders, jacks, and cribbing. Also, be sure you've got the right studs. When you install a blind, the studs you use must be exposed beyond the nut by 1 full thread when tightened, or the blind is not rated at full pressure. Be sure that everyone involved in the work has appropriate safety equipment and personal protective equipment for the situation where you're working. Hazardous material, extreme temperatures, ignitable and toxic gases are some of the conditions that will dictate what you need. Site preparation also includes reviewing the work plan with everyone working on the equipment. All lines, valves, and vessels should be depressurized to atmospheric pressure, drained and purged if necessary. Be sure to follow the correct site-specific written procedures when depressuring, draining, and purging. Other equipment like pumps, air or hydraulically controlled valves, or cathodic protection systems must be isolated by proper lockout tagout. Safety equipment must be available and ready. Once you've gotten all the clearances and permits, done all the preparation work, including purging and bleeding all lines and vessels to atmospheric pressure, and you've locked out and tagged all the equipment you'll be working on, you're ready to place a blind in a line. You can now carefully unbolt the flange, loosening each bolt a little at a time, and check for pressure before removing any bolts. Then you can separate and spread the flange. Before you work on the spread flanges, you should be sure that they're properly supported. If there is residue on the flange when you remove the gasket, use a scraper to clean the flange. Take precautions to avoid placing fingers or hands between flanges. Inspect the gasket to be sure it's in good condition. Then install the gasket. Gaskets and rings must always be installed on the side of the blind that contains higher pressure, but are usually installed on both sides of a blind. The ring joint of the ring-type joint blind must match the ring joint on the flange. Be sure to always use a new ring. Remember that the studs in the flange have to extend past the top of the nut by 1 full thread for the blind to be fully rated. Tighten bolts in a star pattern to the torque setting specified for the required ANSI class rating. Otherwise, the blind may not hold the designed pressure rating. After the blind is secured, clear people and equipment from the area and gradually pressurize the line. This way the line can be depressurized more quickly in case of a leak. Check carefully for leaks. If there is a leak, depressurize the system before you try to fix it. If you can't readily stop the leak by properly torquing the flange, then you'll have to repeat the isolation procedure, disassemble, and check all components carefully for flaws. After installation, tag the blind properly. Remember, the tag should include the name of the person who installed the blind, the date, the detailed reason for blinding, and the blind number that corresponds to the blind list. Flags can be used to identify blinds that are hard to see, and we recommend them for all blinds as a safety precaution, but never install a flag without a tag. Tags are attached either in the hole drilled in the T-handle or the open spectacle end of a blind. There are other fluid isolation methods available when blinding cannot be used. The second best method of fluid isolation is disconnection. The disconnection should be tagged. If possible, a blind flange should be attached to the open end. Double block and bleed is the least desirable method of fluid isolation. It requires that two valves in a line be closed with a full capacity bleed valve opened between them. This method should not be used unless blinding or disconnection is impossible. Double block and bleed can never be used if there's to be a confined space entry or during hot work. Removing a blind is basically the same as installing one, except you do everything in reverse. If you had a permit, make sure it's still in effect, or get a new one. Removing a blind is basically the same as installing one, except you do everything in reverse. All the energy isolation procedures and safety precautions required for blind installation apply to blind removal. That includes lockout tagout, and be sure safety equipment is available and ready. Be sure that a purge procedure has been prepared for returning equipment to service. Purging might require that the last blind be used as a vent location. If any lines have been repressured after blind installation, these need to be depressured to atmospheric pressure and drained. Proper location of blinds, however, can eliminate this step. Now you can carefully unbolt the flange, checking for pressure before removing any of the nuts from the studs. Then remove the blind. Be sure to clean and prep all surfaces and replace gaskets or rings with new, clean ones. Then rejoin the flanges and tighten them in the correct order using the star-shaped pattern. After the flange is reassembled, date and sign the correct number on the blind list to show that the blind has been removed. Before you put the equipment back in service, check that all the flanges are secure. In some locations, the flanges will be taped to assist in checking for leaks. After clearing the area, gradually step up pressure in the line and check for leaks. If there is a leak, you'll need to depressurize and retorque, or drain and disassemble the flange and check the components for problems. Congratulations! You've completed the module on energy isolation. Following the procedures you've learned during the course of this module will help ensure safe working conditions for you and your fellow workers. So until next time, take care and be safe.